This instructional video is designed to show you how to use information we know about half-lives to understand nuclear decay processes. In this case we have chromium-51 and its half-life, and we want to know how long it will take for 5.75 milligrams of chromium-51 to decay to 1.50 milligrams. And so in a problem like this, the first thing you want to do is solve for the rate constant. Because this is a first order process, we know that the half-life is going to be ln 1/2 over minus k. So we rearrange this, then we know that our rate constant k is going to be equal to minus 0.693 divided by the negative of the half-life, 2.78 days. So we can simplify this value, and we get a value for k that's equal to positive 0.0249 with units of 1 over days. The next thing we want to do is take the integrated rate law. Minus kt ln of a naught. And we have the initial amount and we have the final amount. So I'm going to rewrite this in its ratio form. So this would be the amount at time t, and the initial amount, that's equal to minus kt. So now it's possible to actually substitute in everything. The initial amount versus final amount ratio comes up first, and we have 1.50 milligrams as that final amount at time t, and we have 5.75 milligrams as our initial amount. The units cancel out, which is good because the natural log is supposed to be just a pure number. And then we have minus k, 0.0249, 1 over days, times t. And so now it's possible to simplify all of this. We can divide through here and take the natural log, and we get minus 1.34. This is divided by 0.0249. Our units are now days, and that's going to be equal to the time. So when we simplify this all out, we get 53.97 days. And that's equal to the time it takes. And so by being able to use our half-life equation, we can find a rate constant and then plug in the appropriate values into the first order rate equation and determine the amount of time it takes.